Hi everybody, I'm Tim Brzezinski. In this quick screencast, I'm going to show you how you can use GeoGebra to formatively assess students within their journey of learning mathematics concepts. Okay, and basically, again, formative assessment, remember, is assessment that informs the student along the way, informs the teacher along the way. Okay, of their progress. Okay, so let's start here and show you exactly what I mean here. Try to screen share. Oh, hang on a second. Why is it only screen sharing? Here we go. Let's try it again. Share. Application window. There we go. And we are sharing. All right, cool. So basically, right here. All right, you'll see basically this thing called assessment question generators here. It's a GeoGebra book that I created for the most part. And so basically here, this resource contains, I think, over 100, this book contains over 100 resources through which teachers can use to formatively assess students from concepts ranging from arithmetic, literally, or pre-algebra, all the way up through calculus, say right down here, and concepts, say, in between. All right, but let's take a simple one, for example. Typically, in a typical Algebra 1 course, let's say graphing linear equations version 1 or something. Actually, no, let's go even simple. Let's just do slope. Quiz 1. And let's say you want your students, after they discover slope, they learn properties of slope and everything like that, you want them to pretty much be able to find the slope of a line by mere inspection, right? So this question says, hey, read the directions. You got to graph this line to make sure it has slope of -2/5. You see, I created a GeoGebra formative assessment resource here because the feedback that this resource will provide is instant. It's instantaneous, right? You do a CUDA worksheet of, like, say, 8 problems. You know what? You can get 6 or 8 of them wrong. Students will have no idea. But here, you'll know if you're wrong. I could show a hint. I could do whatever. But the slope has to be -2/5. So I could do everything practically wrong that students will do, right? Won't they do, say, this? Oh, 5 and 2, right? 1, 2, 3, 4, 5. Go down one. 5 and 2, and oh my gosh. See, immediately students know if they're correct or not correct. Okay. Now, not every question I think should be like, so maybe, okay, I'll smarten up. Maybe I should do this, 5 and 2, right? Nope, still not right. Oh, right. Rise over run, rise divided by run. Okay, so 2 and then 1, 2, 3, 4, 5. Okay, nope, try again. And so every possible mistake kids can make, they'll probably make, right? But until they actually get it correct. So what happens once they do get it correct? Well, what I would recommend doing is, one means you could do through a purpose of the screencast here is take a screenshot of that. On my Mac, it's Command-Shift-4. It's different for any device you have. Take a quick screenshot, right? And then open up a blank Google document, right? And just say slope questions or something like that, and today's date, whatever. And literally, I can just go to my desktop here and literally find recent here. I could find that item and just put it right in here. Okay, and so basically I'll break the text and hold the shift key down, whatever, and I can make it smaller there to evidence that, hey, I solved at least one question correctly. Now I'm going to go back and do another problem. Okay, so you might ask your students to warm up with maybe 5 or 6 of these for the first few minutes of class, you know, if you will. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, right? That's correct. And so I'll screenshot that thing again. And again, the purpose of the screenshot is for you, the teacher, to simply have evidence that students answer these correctly. Again, these are not high-level thinking tasks, right? This is a depth of knowledge 1, right, or even lower, I would say. But it's just basic knowledge recollection. Should students be able to graph the line with a given slope? Yes, they should. Whatever, we could format that to the cows come home. But you get the basic picture. Have students submit, say, 5 or 6 of these in a Google Doc, and then they could basically go over to the just like right over here, and basically share it with their teacher. Give a comment access or something like that, or edit, whatever. Put the names in there, or you could do it that way. But as a teacher, I wouldn't want to get 8,000 emails from kids. So perhaps you submit this link in some kind of an LMS, such as Google Classroom or Schoology or whatever, right? Get shareable link, there it is. Okay, copy it and paste it to whatever. All right, sky's the limit here. Again, what I'm showing you is not really rocket science, okay? But it's just the means of having students digitally submit, you know, work to you that they have that saves to their Google Drive. You have evidence of it there in, you know, your LMS that you can see student work, okay? And that's pretty much kind of how it goes. So that's all I really wanted to show you here. So again, the lower level the task, you know, that the students do, the more immediate the feedback needs to be. in my opinion. But obviously, we don't want to stick with DOK low-level, DOK1 low-level thinking questions. Yeah, we ask a few, sure, basic knowledge recollection, but we want to eventually, ask higher-level thinking questions where students have to create, construct, or evaluate. Okay, now those types of tasks through which you can engage students, feedback should not be instantaneous. It should take time. They reflect. You have to look at it, reflect, and so on and so forth. So I created all those resources in GeoGebra simply because, you know what? For the DOK1 questions that you ask students to do here and there, you have a means through which they can simply show you evidence of their progress. So I'm Tim Brzezinski. Thanks for watching. And if you like what you see, feel free to subscribe. A lot more GeoGebra videos coming next week. And yeah, I wish you much success on your journey of teaching and or learning mathematics. Have a great day.